May 20th, 1943. Aberdeen, Proving Ground, Maryland. In the American test bay sits the most feared weapon of the Second World War, Tiger 712. 57 tons of German engineering superiority, the 88mm gun that could punch through any Allied armor at 2,000 yards. Krupp steel plates 8 inches thick. Every specification sheet told the same story. This machine dominated every American tank in raw performance. Staff Sergeant Jim Morrison, Detroit toolmaker turned tank mechanic, received orders that seemed like a gift. Figure out how to maintain captured Tigers when American forces overrun more of them in Europe. His crew could swap a Sherman engine in 4 hours using basic field tools. How hard could German engineering be? For 48 hours, Morrison's team marveled at the precision. Every component machined to jouled tolerances. The Maybach engine, a masterwork of metallurgy. Then Tiger 712 threw its first track during a simple test run. What should have been a 2-hour fix stretched into 3 days of hell. To reach one damaged road wheel, they had to remove 9 overlapping wheels first, each weighing 180 pounds, with tools that didn't exist in American inventory. Morrison was discovering something the Wehrmacht never told their crews. This tank that devours its own drivetrain in the field is worse than worthless. The morning sun cast long shadows across the Aberdeen Proving Ground as Staff Sergeant Jim Morrison approached the massive steel hulk that would define the next 6 months of his life. Tiger 712 sat motionless in the test bay, its dark gray paint still bearing the scars of whatever battle had claimed it from German hands. At 57 tons, it dwarfed every American tank Morrison had ever worked on, yet something about its presence felt less like triumph and more like a challenge waiting to devour the unwary. Morrison had built his reputation on solving the unsolvable. In Detroit, he'd coaxed life from broken-down assembly line machinery when production quotas hung in the balance. In North Africa, his maintenance crew had kept Sherman tanks rolling through sandstorms that clogged air filters and seized transmissions. The Army had handpicked him for this assignment because when Jim Morrison said a machine could be fixed, it got fixed. When he said it couldn't, commanders listened. Corporal Danny Williams whistled low as he circled the Tiger, his farm boy instincts already cataloging details that would matter when things broke down. "Look at the size of them road wheels," he said, running a calloused hand along the overlapping suspension bogies. "Gotta be twice the diameter of a Sherman's. Bet that ride's smooth as butter." Williams had grown up nursing temperamental John Deere tractors through Kansas winters, and he recognized quality engineering when he saw it. Sergeant Pete Kowalski stood at the Tiger's rear, examining the massive final drive housing with the critical eye of a man who'd spent 15 years on Chrysler production lines. "Sophisticated," he muttered, noting the precision machined components visible through the access panels. "Real sophisticated. Question is whether all this sophistication translates to battlefield reliability." Kowalski understood the difference between engineering excellence and manufacturing practicality, and something about the Tiger's complexity already troubled him. Morrison climbed onto the Tiger's engine deck and peered into the power plant compartment. The Maybach HL 210 engine gleamed with Germanic precision, every component machined to tolerances that put American manufacturing to shame. Fuel lines routed with mathematical precision. Cooling systems that belonged in a luxury automobile rather than a combat vehicle. The transmission case alone probably cost more to manufacture than an entire Sherman power pack. "Gentlemen," Morrison announced, dropping down from the engine deck, "we've got ourselves a thoroughbred. Question is whether thoroughbreds belong in a dogfight." He pulled out the clipboard containing their orders. The directive was simple enough on paper. Evaluate the Tiger's maintainability under American field conditions. Determine whether captured Tigers could supplement American armored strength in the European theater. Provide recommendations for maintenance procedures, parts requirements, and crew training protocols. Williams had already opened the Tiger's massive tool compartment, revealing specialized wrenches and precision instruments that looked more like surgical equipment than field maintenance gear. "Never seen anything like these tools," he said, hefting a complex track tension adjustment device that probably weighed 30 pounds. "Back home, we fixed everything with a hammer, some wire, and whatever parts we could scrounge from the junkyard. This here's a whole different philosophy." Kowalski was examining the track system, noting how the interleaved road wheel configuration distributed the Tiger's enormous weight across a broader surface area. "Engineering-wise, it's brilliant," he admitted. "Gives you better ground pressure distribution than anything we've built. But look at this complexity." He pointed to where each road wheel overlapped with its neighbors, creating a maze of steel that would need to be navigated during any suspension repair. "You want to change one damaged wheel? You got to remove half the suspension to reach it." Morrison began his systematic inspection at the bow machine gun port, working his way methodically around the hull. The armor thickness impressed him. 8 inches of face-hardened Krupp steel that could deflect any American anti-tank round currently in service. The gun mantlet alone weighed more than some entire Sherman turrets. But it was the details that began to worry him. Every component seemed engineered for perfection rather than repairability. Precision where pragmatism might serve better. Complexity where simplicity would save lives. The crew spent their first week simply learning the Tiger systems. The Maybach-Olvar transmission required adjustment procedures so precise that German maintenance manuals specified temperatures and humidity levels for optimal results. The interleaved suspension system provided an incredibly smooth ride but demanded specialized lifting equipment to service individual components. The famous 88mm gun moved with jeweled precision, but its loading mechanism required lubricants that didn't exist in American supply chains. Williams mastered the Tiger's starting procedure, a complex sequence of fuel pump priming, transmission preheating, and electrical system checks that took 12 minutes under ideal conditions. "Sherman fires up in 30 seconds, he noted in his maintenance log. "Push the button. She starts. This Tiger's got more steps than Sunday morning church service." Kowalski focused on the parts inventory, cross-referencing German component specifications with American manufacturing capabilities. The news wasn't encouraging. "Half these parts would take 6 months to manufacture stateside," he reported to Morrison. "The other half, we don't have the metallurgy to produce at all." Everything's engineered to German industrial standards that assume German supply chains. Morrison absorbed their reports while developing his own assessment of the Tiger's operational philosophy. This wasn't just a tank. It was the embodiment of a completely different approach to armored warfare. Where American doctrine emphasized mechanical reliability and field repairability, German engineering pursued individual superiority at any cost. The Tiger represented the ultimate expression of that philosophy, a weapon so advanced that it seemed to transcend the messy realities of combat maintenance. Then came the moment that would define everything that followed. During a routine mobility test on Aberdeen's obstacle course, Tiger 712 threw its left track at kilometer marker 12. Morrison checked his watch. What should have been a standard 2-hour track repair was about to become their introduction to German maintenance philosophy. The mathematics of fuel consumption delivered the first shock that would reshape Morrison's understanding of German armor doctrine. Tiger 712's Maybach engine consumed gasoline with an appetite that defied rational military logistics. During cross-country trials at Aberdeen, the massive tank burned through 5 gallons for every mile of rough terrain, compared to the Sherman's economical 2 gallons per mile. With the Tiger's 125-gallon fuel capacity, Operational range dropped to a devastating 68 miles before refueling became mandatory. Morrison stood beside the fuel depot, watching his crew top off the Tiger's tanks for the third time in 2 days. "Danny, run those numbers again," he called to Williams, who was calculating consumption rates with the methodical precision of a farmer planning seed purchases. "Cross-country at combat speed, we're looking at 25 miles per 100 gallons," Williams reported, his Kansas practicality cutting through the impressive statistics that had initially dazzled them. "That Sherman over there would cover 60 miles on the same fuel load. In tank warfare, Sergeant, range equals tactical flexibility. This Tiger's got the firepower of a battleship, but it's anchored to fuel depots like a harbor defense gun." Kowalski emerged from beneath the Tiger's hull, grease-stained and frustrated after wrestling with the complex final drive system. His Chrysler production experience had taught him to recognize engineering decisions that prioritized performance over maintainability, and the Tiger's drivetrain embodied every mistake he'd seen magnified to absurd proportions. "Jim, come look at this final drive housing," he called, his voice carrying the weight of unwelcome discovery. Morrison crawled under the massive tank, following Kowalski's flashlight beam to the transmission's connection point with the drive sprockets. What he saw challenged everything he thought he understood about combat vehicle design. The final drive mechanism was a masterpiece of precision engineering and a maintenance nightmare that would destroy crews in combat conditions. "See how they've integrated the transmission output directly into the drive sprocket assembly?" Kowalski explained, pointing to components that seemed to flow seamlessly into one another. "Beautiful engineering, perfect for maximum power transfer efficiency. But when this unit fails, and it will fail under combat stress, you can't just swap out the broken part. The whole assembly comes out as one piece. Requires specialized lifting equipment, precision alignment tools, and probably 8 hours of workshop time." Morrison absorbed this information while calculating its tactical implications. In fluid combat situations, 8 hours might as well be 8 days. Enemy forces wouldn't pause their advance to accommodate German maintenance schedules. American tank crews expected to complete similar repairs in 90 minutes using standard field tools and whatever improvised equipment they could scrounge. The crew's education in German maintenance philosophy accelerated when they attempted their first major component replacement. A hydraulic line in the Tiger's turret traverse system had developed a leak during firing tests, spraying pressurized fluid across the fighting compartment. In a Sherman, Morrison's crew would have isolated the damaged section, cut out the bad line, and spliced in a replacement using standard fittings available in any maintenance depot. The Tiger's hydraulic system operated on different principles entirely. Every component was precisely calibrated to work within narrow tolerances that demanded exact pressure specifications, fluid temperatures, and system pressures that couldn't be approximated or field expedient. The replacement hydraulic line existed only in German parts inventories, manufactured to specifications that American industry didn't recognize. Williams spent 2 days fabricating a replacement line using American components, only to discover that his perfectly functional repair created pressure fluctuations that threw off the turret's electrical systems. "It's like they designed every piece to depend on every other piece," he reported to Morrison. "Change one component and you've got to recalibrate systems 3 levels deep. Back home, we believed in fixing what's broken and leaving everything else alone. This machine doesn't work that way." The Tiger's interleaved road wheel suspension system provided their most brutal education in German engineering philosophy. During a routine maintenance inspection, Kowalski discovered stress fractures in the number 4 road wheel on the left side, a component that would require replacement before the Tiger could safely operate at combat speeds. Morrison gathered his crew around the damaged suspension to plan their repair approach. In a Sherman, Removing a road wheel required unbolting 4 fasteners and lifting out the damaged component using a standard maintenance jack. The Tiger's overlapping wheel configuration transformed this simple job into an engineering puzzle that would test their mechanical ingenuity and their patience. To reach that cracked wheel, we've got to remove wheels 3, 5, and 6 first, Morrison explained, studying the German maintenance manual with growing disbelief. Each wheel weighs 180 pounds and requires specialized lifting fixtures that don't exist in American inventory. The manual calls for an overhead crane capable of precise positioning within quarter-inch tolerances. Williams examined the wheel overlap pattern with the systematic approach he'd learned servicing complex farm machinery. "Sergeant, this system might ride smooth and distribute weight better than anything we've built, but it's designed by men who never had to fix one under fire. Every wheel depends on its neighbors. Damage one component, and you're looking at major disassembly to reach it." The wheel replacement consumed 36 hours of intensive labor. Morrison's crew improvised, lifting solutions using Aberdeen's workshop equipment, fabricated alignment tools from steel stock, and developed procedures that German manuals never contemplated. By the time they'd completed the repair, all 3 men understood that they'd crossed a threshold in their relationship with Tiger 712. Kowalski articulated what they'd all begun to realize. This isn't just complex engineering. It's engineering that assumes perfect conditions, unlimited time, and specialized facilities for every repair. The Germans built a tank that performs magnificently when everything works perfectly, but becomes a maintenance black hole the moment reality intrudes on their theoretical world. Morrison documented every hour, every failed procedure, every improvised solution in reports that would eventually reach tank commanders preparing for the invasion of Europe. The Tiger's individual superiority was undeniable, but superiority that couldn't be sustained operationally might prove worse than useless in the fluid campaigns ahead. For 6 weeks, Morrison's crew achieved something approaching mastery over Tiger 712's complex systems. They developed workarounds for hydraulic pressure irregularities, created field-expedient solutions for electrical gremlins that plagued the turret traverse motor, and even fabricated replacement gaskets using American materials when German specifications proved impossible to source. The massive tank responded to their growing expertise, purring through Aberdeen's test courses with the smooth precision that had made Tigers legendary on European battlefields. Williams had become the Tiger's unofficial interpreter, translating the subtle vibrations and mechanical whispers that preceded component failures. His farm boy intuition, honed on temperamental tractors that demanded constant attention, proved surprisingly applicable to German over-engineering. "She's talking to us now," he reported to Morrison after a particularly smooth gunnery exercise. "Listen to how that final drive whines on hard turns. That's normal for this machine. When it goes quiet, that's when you worry." Kowalski had mapped every maintenance procedure, creating detailed checklists that transformed German theoretical perfection into practical American maintenance doctrine. His Chrysler experience with precision manufacturing helped him understand the Tiger's demanding tolerances, while his production background taught him to identify which specifications could be safely approximated using available materials. "We're getting there, Jim," he told Morrison. "Another month, and we'll have procedures that could keep captured Tigers operational in the field." Morrison felt cautiously optimistic as he drafted preliminary reports for Aberdeen's command structure. The Tiger's complexity was undeniable, but American mechanical ingenuity had overcome worse challenges. His crew represented the pragmatic problem-solving spirit that had transformed American industry from civilian production to military dominance in less than 2 years. If Detroit assembly lines could build Liberty ships in weeks rather than months, Surely American mechanics could master German tank maintenance. Then the research division delivered historical context that shattered Morrison's growing confidence. Intelligence reports from captured German maintenance companies revealed operational patterns that contradicted everything the Tiger's impressive specifications suggested. The elite 503rd Heavy Tank Battalion, equipped with the newest Tigers and manned by Germany's most experienced crews, regularly reported 30% of their tanks inoperable due to mechanical failures before engaging enemy forces. The numbers painted a disturbing picture of German armor operations. Tiger units required 8 to 10 hours of maintenance work for every operational hour, compared to American Sherman units that maintained combat readiness with 2 to 3 hours of daily maintenance. German tank recovery companies dedicated entire workshops to supporting single Tiger battalions, while American armored divisions kept multiple Sherman battalions operational using standardized depot-level maintenance that could be performed anywhere with basic tools. Morrison studied captured German maintenance logs with growing alarm. Unit after unit reported identical patterns. Final drive failures every 400 to 500 kilometers of combat operation. Transmission overhauls required after brief periods of intensive maneuvering. Track replacement schedules that consumed more time than actual combat missions. The Wehrmacht's most feared weapon was consuming more resources than it produced tactical advantage. Williams discovered the most damning evidence while researching cold weather operations. German reports from the Russian front described Tigers regularly becoming immobilized not by enemy action, but by their own suspension systems. When mud and debris packed between the overlapping road wheels and froze solid, the entire interleaved system locked up, transforming 57 tons of steel into stationary targets. Soviet forces had learned to wait for winter weather, knowing that German maintenance crews couldn't keep their sophisticated tanks mobile in conditions where T-34s continued fighting. "Sergeant Morrison," Williams reported, his voice carrying the weight of unwelcome revelation, "according to these German documents, Tiger crews in Russia spent more time digging frozen mud out of their suspension than they did fighting. That beautiful engineering we've been admiring turns into a maintenance nightmare the moment conditions get messy." Kowalski's analysis of German parts consumption provided equally troubling insights. Each Tiger required specialized components manufactured to tolerances that demanded precision tooling and exotic materials. Track pins machined from high-grade steel that took weeks to produce. Final drive gears that required heat treatment processes unavailable in field workshops. Hydraulic seals made from synthetic rubber compounds that didn't exist in most industrial nations. The Germans built a tank that can only be maintained by German industry, Kowalski concluded. Every critical component depends on manufacturing capabilities that took them decades to develop. Capture a Tiger, and you've captured a machine that will consume your maintenance capacity while giving you nothing sustainable in return. Morrison absorbed these revelations while Tiger 712 underwent Aberdeen's most demanding test yet. 200 miles of continuous cross-country operation designed to simulate sustained combat conditions. For the first 150 miles, the Tiger performed magnificently, its sophisticated suspension soaking up terrain that would punish lighter tanks, its powerful engine maintaining steady speed across obstacles that might slow American armor. At mile 168, the Tiger's final drive began producing metallic grinding sounds that Williams immediately recognized as bearing failure. By mile 175, transmission temperatures exceeded safe operating limits despite perfect weather conditions and careful driving. The track pins that had seemed indestructible began shearing under stress loads that Sherman tracks absorbed routinely. At mile 180, Tiger 712's final drive ceased completely, locking the right track and bringing the massive tank to a grinding halt in Aberdeen's test area. Morrison climbed down from the driver's position, knowing that his 6 weeks of optimism had just collided with German engineering reality. The post-mortem examination revealed the Tiger's fundamental weakness. Components designed for theoretical perfection had failed under conditions that American tanks considered routine. The precision manufacturing that created such impressive individual performance had produced a machine too delicate for the warfare it was meant to dominate. Morrison realized that his crew hadn't been maintaining a combat weapon, they'd been nursing a mechanical thoroughbred through conditions that would destroy it. As Kowalski began calculating repair requirements, Morrison understood that Tiger 712 had taught them its most important lesson through failure rather than success. Morrison spread the maintenance logs across Aberdeen's workshop table. The brutal mathematics of Tiger 712's operational reality laid bare in columns of unforgiving numbers. 40 maintenance man-hours required for every single operational hour, compared to 8 hours for comparable American tanks. Parts consumption rates that tripled standard replacement schedules, fuel requirements that limited tactical deployment to defensive positions within 68 miles of supply depots. The famous 88mm gun became irrelevant if the tank couldn't reach the battlefield or remain mobile once engaged. Williams stood beside the crippled Tiger, its seized final drive housing already partially disassembled, to reveal the precision gears that had destroyed themselves under combat simulated stress. "Sergeant, look at these gear teeth," he called, holding up components that seemed more like jewelry than military hardware. They're machined to tolerances that would make a Swiss watchmaker proud, but they can't handle the kind of abuse that a Sherman final drive absorbs every day without complaint. The gear teeth showed stress patterns that told a clear story of engineering philosophy colliding with operational reality. German metallurgy had created components capable of transmitting enormous power with minimal friction loss, but the same precision that enabled such efficiency made the gears vulnerable to shock loads and contamination that American designs absorbed routinely. Morrison examined the failed components with the eye of a mechanic who understood that theoretical superiority meant nothing if it couldn't survive contact with combat conditions. Kowalski emerged from beneath a Sherman tank that had been undergoing routine maintenance in the adjacent bay. The contrast between American and German maintenance philosophy couldn't have been starker. Where the Tiger demanded specialized tools, precision alignment fixtures, and workshop conditions, the Sherman yielded to standard wrenches, improvised lifting equipment, and field expedient solutions that kept tanks fighting regardless of conditions. "Jim, watch this," Kowalski said, demonstrating a transmission repair on the Sherman using tools available in any American maintenance kit. Transmission output shaft bearing failure, exactly the same type of problem that killed our Tiger. On the Sherman, we pull 4 bolts, swap in a replacement bearing from depot stock, and she's back in service in 2 hours. Total parts cost $8.30. Morrison calculated the comparable repair requirements for Tiger 712. The specialized bearing assemblies would require factory production using German tooling and metallurgy. Installation demanded precision alignment procedures that couldn't be performed without workshop facilities. Even if replacement parts were available, the repair would consume 3 days of intensive labor by specialized technicians. The parts cost alone would exceed the price of an entire Sherman transmission. The crew conducted side-by-side maintenance comparisons that revealed the true scope of German over-engineering. Sherman crews could perform engine swaps, transmission overhauls, and complete track replacement using standard field tools and components available through normal supply channels. Every American tank component was designed for replacement by minimally trained personnel under adverse conditions, reflecting a military philosophy that valued operational sustainability over individual unit performance. Tiger maintenance required factory-trained specialists, precision instruments that didn't exist in American inventory, and components that took months to manufacture using processes that American industry didn't recognize. The Tiger's superiority in individual performance became meaningless when that performance couldn't be sustained through extended operations. Williams documented the most revealing comparison when he attempted to perform identical repairs on both tanks simultaneously. Replacing a damaged road wheel on the Sherman required 37 minutes using standard maintenance procedures and tools available in any armored unit. The identical repair on Tiger 712 consumed 11 hours, required specialized lifting equipment, and demanded disassembly of multiple systems to access the damaged component. "It's not just complexity," Williams reported to Morrison. "It's complexity that assumes you've got unlimited time, perfect conditions, and a fully equipped workshop. The Germans designed this tank for peacetime maintenance schedules, not combat operations where you've got to fix things fast or die trying." Morrison compiled the final statistics that would define his report to Aberdeen Command. Operating one Tiger in sustained combat required the same logistical footprint as maintaining 3 Sherman tanks. The Tiger's fuel consumption alone limited tactical flexibility to defensive operations, while its maintenance requirements consumed resources that could support entire American armored companies. German engineering excellence had created a weapon that defeated itself through its own sophistication. The emotional weight of these conclusions pressed on Morrison as he prepared his final assessment. His crew had begun this assignment with professional excitement about German engineering superiority, expecting to unlock the secrets of Wehrmacht armored dominance. Instead, they discovered that German armor doctrine represented a fundamental misunderstanding of mechanized warfare's true requirements. Kowalski articulated the strategic implications with the clarity of a man who understood industrial capacity. The Germans built tanks like luxury automobiles, magnificent individual machines that require specialized support infrastructure. We built tanks like farm tractors, reliable, maintainable, and designed to keep working under any conditions a farmer might encounter. In extended warfare, the tractor philosophy wins every time. Morrison's preliminary report traveled through military channels with conclusions that challenge prevailing assumptions about German technological superiority. American armor doctrine's emphasis on reliability, maintainability, and logistical sustainability represented a different kind of engineering excellence, one that prioritized sustained operational capability over peak individual performance. The mathematical proof was undeniable. Tiger 712 sat silent in Aberdeen's workshop, requiring complete powertrain reconstruction to return to operational status. Total maintenance hours invested, 2,180. Total operational hours achieved, 87. Final drive failures, 3. Track changes required, 12. The arithmetic had always been clear. They'd simply needed time to prove it. As Morrison drafted his final recommendations, he understood that his crew had uncovered something more significant than maintenance procedures. They'd revealed the fundamental weakness in German military thinking, the belief that individual superiority could overcome systemic disadvantages. In warfare, sustainable adequacy defeated unsustainable excellence every time. Morrison sat in Aberdeen's administration building, staring at the typewritten report that would define his professional reputation and potentially influence American armored strategy for the remainder of the war. The conclusion was stark. uncompromising, and certain to disappoint commanders who had expected German engineering superiority to supplement American armored strength. Tiger tanks are unsuitable for sustained field operations under American maintenance doctrine. Recommendation: do not attempt to maintain captured Tigers beyond immediate tactical exploitation. The words carried the weight of mathematical certainty, but Morrison understood the human cost of his honesty. His superiors had invested 6 months and considerable resources in this evaluation, expecting to hear that American ingenuity could overcome German complexity. The data told a different story, one that challenged fundamental assumptions about the relationship between individual weapon performance and overall military effectiveness. Williams found Morrison in the workshop later that evening, both men drawn back to Tiger 712, as if the silent machine might somehow reveal different truths under different lighting. The massive tank sat motionless, its engine compartment open to expose the Maybach power plant that had consumed more maintenance hours than it had delivered operational capability. "You think they'll listen, Sergeant?" Williams asked, his Kansas practicality cutting through the complexity of military politics. "They'll listen to the numbers," Morrison replied, running his hand along the Tiger's fender with something approaching affection despite everything the machine had taught them about German engineering philosophy. "Question is whether they'll accept what the numbers mean. This tank represents everything impressive about German industry, but it also represents why impressive isn't always effective." Kowalski joined them beside the Tiger, carrying maintenance logs that documented every failure, every impossible repair requirement, every hour of specialized labor that American field units couldn't possibly provide. His Chrysler experience had taught him to recognize when engineering excellence became counterproductive, and Tiger 712 embodied every mistake he'd seen in civilian manufacturing magnified to military proportions. "The report's already traveling up the chain," Kowalski reported. Aberdeen Command forwarded it to Ordnance Department, who sent copies to every armored division preparing for European operations. "Tank commanders are going to read that we recommend abandoning captured Tigers rather than trying to maintain them." Morrison absorbed this news while calculating its implications for American armor doctrine. His crew's work would influence decisions being made by commanders who faced the prospect of encountering hundreds of Tigers during the invasion of Europe. The lesson was clear. American armored superiority lay not in individual tank performance, but in the ability to keep tanks fighting through extended campaigns. The historical vindication for Morrison's conclusions was already emerging from European battlefields. Intelligence reports from Italy described German Tiger units regularly reporting 50% operational readiness due to mechanical failures rather than combat losses. American Sherman units, by contrast, maintained 85 to 90% operational strength through extended campaigns, their reliability and maintainability proving decisive in fluid combat situations. Williams had been studying captured German maintenance reports from the Russian front, finding patterns that confirmed everything they'd discovered at Aberdeen. "Sergeant, look at these numbers from the 502nd Heavy Tank Battalion," he said, spreading documents across the Tiger's engine deck. 45 Tigers deployed to Leningrad sector. After 3 months of operations, only 12 remained combat capable. 21 broken down awaiting parts, 8 abandoned due to transmission failures, 4 destroyed by crews who couldn't repair them under combat conditions. The contrast with American operations was striking. Sherman-equipped armored divisions maintained combat effectiveness through campaigns that lasted months rather than weeks. Their standardized maintenance requirements compatible with field logistics that could support sustained offensive operations. The Tiger's individual superiority became meaningless when that superiority couldn't be sustained operationally. Kowalski had been analyzing production statistics that revealed the strategic weakness underlying German armor philosophy. They're building tanks like they're building precision instruments, he observed. Each Tiger requires manufacturing resources that could produce 3 Panthers or 5 Panzer IVs. But all that precision manufacturing creates weapons too complex for the war they're fighting. Morrison understood that his crew had uncovered something more significant than maintenance procedures. They'd revealed the fundamental flaw in German military thinking, the belief that technological superiority could overcome logistical reality. American armor doctrine recognized that sustained adequate performance defeated unsustainable excellence in extended warfare. The report's influence became apparent within weeks as American armored units received modified tactical guidance regarding captured German equipment. Rather than attempting to maintain Tigers for extended operations, field commanders were instructed to exploit captured tanks for immediate tactical advantage before abandoning them when maintenance requirements exceeded field capabilities. Morrison's recommendations shaped American tank development philosophy for the remainder of the war and beyond. The lesson learned from Tiger 712 influenced the design of post-war American armor, emphasizing reliability and maintainability over peak individual performance. Combat effectiveness depended not on engineering perfection, but on sustained operational capability under adverse conditions. As autumn approached Aberdeen, Morrison's crew conducted their final evaluation of Tiger 712. The massive tank had taught them that German engineering excellence represented a different kind of failure. The failure to understand that weapons must be designed for the war they'll actually fight rather than the war their engineers imagine. Williams performed the shutdown procedures one final time, his movements now automatic after months of intimate familiarity with German over-engineering. "Strange thing, Sergeant," he observed as the Maybach engine fell silent. "This is probably the most sophisticated tank ever built, but it taught us why sophistication isn't always smart." Tiger 712 now sits in Aberdeen's collection, a testament to engineering excellence that defeated itself through its own complexity. The final statistics tell the complete story. 87 total operational hours achieved through 2,180 hours of maintenance work. 3 final drive failures requiring complete powertrain reconstruction. 12 track changes consuming more time than actual combat operations. The arithmetic was always clear. American pragmatism had simply needed time to prove it against German theoretical perfection. The Tiger that was supposed to supplement American armored strength had instead revealed why American armor doctrine would prove superior in sustained warfare.